Good morning, dear students. Today I will discuss about the BSc course. Topic name is polarization. Dear students, we are going to discuss about the define polarizations. Okay, the phenomena due to which vibration of light waves are restricted in a particular plane is called polarizations. Now, dear students, the vibration of light waves or the restricted in particular plane is called as the polarization. In an ordinary beam of light from a source, the vibration occur normal to the direction of propagation in all the possible planes. Such beam of light called unpolarized light means direction of propagation of possible planes, in which means vibrations or the light from the sources at the direction of propagation in all possible planes. Such a beam of light is called unpolarized light. Some reflection, refraction or scattering of the some methods are there. Beam of light is produced in which vibration are confined to only one plane, then it is called as a plane polarized light. Hence, polarization is the phenomenon of producing plane polarized light from unpolarized light. See here, dear students, in plane polarized light, the plane containing the direction of vibration and propagation of light is called plane of vibration. See here diagram. Okay, the plane which perpendicular to the plane of vibration is called the plane of polarizations. Okay, but is the first one diagram is the unpolarized light, means the directions there are plane of vibrations. Okay, then the plane of vibration or E plane of polarizations. Okay, dear, A, B, C, D, that is the plane of or represents the plane of vibrations, such as E, F, G, H. It represents the plane of polarization, that is the E, H, G, F. These are the plane of polarization. A, B, C, D, these are the plane of vibrations. Okay, there are three types of polarized light. One is the plane polarized light, second one is the circularly polarized light, then third one is the elliptically polarized light. Okay, first one is the plane polarized light, second one circularly polarized light, and then the elliptically polarized light. Okay, now important topic or important Huygens theory of double refraction. This is most important in concept. Okay, according to Huygens theory, a point of W refracting or bifringent crystals produce two types of wavefronts. Okay, the wavefront corresponding the O over A is called the spherical wavefront. The ordinary wave travels with the same velocity in all directions, means, and the sum of the corresponding wavefront is, that is the spherical. Okay, the wavefront corresponding to the E ray is ellipsoid wavefront. Extraordinary waves have different velocity in all different direction, so the corresponding wavefront is the elliptical. Means elliptical means the wavefront corresponding the E ray is ellipsoid. It means wavefront extraordinary waves have different velocity, means different direction, or corresponding to the wave is called the elliptical. Means the first one is the negative crystals and the positive. There are two types of there. Double Huygens theory of double refraction. First one is negative crystals, second one is the positive crystals. Negative crystals, the negative crystals are the crystals which a refractive index corresponding to the E ray. Means E ray means the n neta is the less than the refractive index corresponding to the O ray, ordinary way and extraordinary way. These are the two types of the rays. Then all the direction expect the optic axis. Okay, the E ray on the extraordinary A travels faster than the ordinary wave, expect along the optic axis. The spherical extraordinary wavefront is entirely within the ellipsoid E wavefront. For example, calcite, tourmaline and ruby. Then positive crystals. Positive crystals are the crystals in which refractive for O ray is less than that or that for the E ray neta greater than neta E. Ordinary is less than extraordinary ray. The velocity of ordinary ray is greater than or equal to the velocity of extraordinary ray. The ellipsoidal wavefront is entirely within the spherical O wavefront. For example, quartz, satellites and rotels. So this is the optical axis, extraordinary ray and ordinary ray, that is the less than or equal to extraordinary ray. The optic axis is the extraordinary is greater than ordinary ray, that is the positive crystals. The extraordinary is a less than ordinary ray, that is the negative crystals. Extraordinary is greater than ordinary ray is the positive crystals. It means the entirely spherical wavefront, that is the equal to the velocity. Okay. Then types of retardation plates. Okay. Then is the first one is the quarter wave plate and half wave plate. Okay. Now I will skip the important concept. Okay, analysis of polarized light. Okay, now we are going to discuss about the, see here diagram, let monochromatic light is incident on, that is the Nicol prism. After passing through at height at light is plane polarized and it is incident normally on double refracting crystals. Polarized light, the plane polarized light entering into the crystal split up into component, that is ordinary and extraordinary. Both light components travels along the same direction but at different velocity. Let the thickness of these crystals this produce phase difference and delta between ordinary ray and extraordinary ray theory. Suppose the amplitude of the incident plane polarized light in a crystal A, that is the A is the incident plane polarized light as a crystal is A and it makes angle, that is angle theta with the optic axis. Amplitude ordinary ray vibrating along PO is A sin theta and the amplitude of extraordinary ray vibrating along polarization or rays after passing through the thickness crystals. So coming out of the crystals can be represented, it means the in terms of two simple harmonic motions. For extraordinary ray, that is the x equal to a cos theta into sin theta into omega t into plus delta. For extraordinary ray, y equal to a sin theta omega sin theta into omega, that is let a cos theta equal to a and a sin theta equal to b. Now x equal to a sin omega t plus delta, this is equation number 1. Y equal to b sin omega t, that is equation number 2. From equation number 2, y equal to b sin omega t, that is the y divided by b equal to sin omega t. This is equation number 3. Cos omega t equal to root of 1 minus y square divided by b square, that is the LHS side, that is the 1 minus, that is the negative sign indicates that 1 minus y square divided by b square, that is equation number 4. From equation number 1, x equal to a sin omega t plus delta. Okay, from equation 1, then x by a sin omega t plus delta, x by a equal to sin omega t cos delta plus cos omega t sin delta. From equation 3 and 4, from above equation becomes, okay, equation 3 and equation number 4, that is the x by y a equal to y by b cos del plus root of 1 minus y square by b square sin del. X by a minus y by b cos del equal to root of 1 minus y square by b square sin del. Squaring on the both sides, x square divided by a square plus y square by b square cos square omega del minus 2xy divided by ab cos del equal to 1 minus y square by b square into sin square del. That is the x square by a square plus y square by b square cos square del minus 2xy by ab cos del equal to sin square del minus y square divided by b square sin square del x square divided by a square plus y square by b square cos square del plus sin square del minus 2xy by ab cos del equal to sin square del. This is equation number 5. Then the special cases there are when del equal to 0. Equation pi is, that is the x by a minus y by b whole square equal to 0, y by b equal to x by a, then y equal to b minus b by a into x. This gives the straight line. Therefore emergent light is plane polarized. Then case number 2, del equal to 5 by 2 and a is not equal to b. Equation pi becomes x square divided by a square plus y square divided by b square equal to 1. This represents the equation of symmetrical ellipse. In this case of emergent light, it will be elliptically polarized provided a is not equal to b. Case number 3, when del equal to 5 by 2 and a equal to b, equation pi becomes x square plus y square equal to a square. It means the represent the equation of circular radius. In this case of emergent light will be circularly polarized. Hence, the case vibration of plane polarized at light of crystals make the angle of 45 degree in the direction of the optical axis. Okay, now dear students, the production of the polarized light. One is the plane polarized light, circularly and elliptically polarized light. Then third one is the first one and second one. First one is the plane polarized light, then second one is the circularly and elliptically polarized light. Okay, now the most concept is important concept, Fresnel theory of optical rotations.